motion by a rigid body. In this, the important word is the rigid body. Rigid body is a body such that if there are n particles, all these n particles are free to move at whatever velocities they are acquired according to the forces applied with them, but with one condition, that distance among these particles individually should always remain constant. Meaning, we can also write this in a mathematical way, that if Ri is the distance of the ith particle and Rj is the distance of the jth particle, will always remain constant. We can understand this in a better way, that taking an example of a two particle system, which is the simplest of all the rigid bodies. Let us take this point to be origin, and this is our first particle and this is our second particle. The distance between these two particles can be calculated on the basis that this is distance of the first particle is r1 from the origin, and distance of the second particle is r2 from origin. Then distance between r1 and r2 will be r1 minus r2, and these can be taken as vectors also. The direction of this would be from 2 to 1. This r1 minus r2 should always remain constant. If we place such a constraint, the motion of these two objects or the rigid body is constrained heavily. We will try to understand the motion of the rigid body with the example of two body system itself. This is our two body. It can, or it is free to move, first of all, along three different axes. First is the x-axis, second along y-axis, and third along z-axis. So our molecule or two body system is free to move these three motions, meaning it has three linear degree of freedom. Also, this object can rotate about this axis and also about this axis. It also has one option to rotate about this axis, which is passing through the center of it. There could be n such or infinite such axes about which it can rotate. So there exists the second degree of freedom as rotational degree of freedom. Obviously, other than these two degrees of freedom, there is no other possibilities left for it. These two particles cannot move to their independent paths because this distance has to remain constant. Also, these two particles cannot vibrate, as when they vibrate, they will move forward and back from their mean position, which will going to increase the distance between them, and it will violate the essential condition of rigidity. So these are the only two possible motions which are available for any rigid body. We have just discussed a case of a two body system, but it can easily be extended to an n body system, in which also only these two kind of different motions are available for the system.